Hi, welcome to the introduction to agentscript.org. I'm your host, Stephen Guerin. I'm the founder of Redfish and SimTable. With me are Owen and Benny. Benny, and can you introduce yourself?
Yep. Hi, I'm Benny. I grew up in New Mexico, live in Oakland now, and I've been working with Owen and Steven on making a way to approach writing agent-based models in your browser, which I care about because that was kind of my introduction to programming and scientific programming and complexity science.
Hi, I'm Owen Densmore. I had a long career in Silicon Valley working for Xerox Research and then um, Apple working on the Macintosh, the very first one, and then Sun Microsystems. And I'm working now with Stephen and Redfish as the designer for agent-based modeling system that runs in the browser that's modeled after NetLogo.
Great, thank you, Owen. And that's just a quick point of that. If Benny, you can bring up the website agentscript.org. We're all here in Santa Fe and very interested in complex systems. And one of the tools of that is agent-based modeling. And a lot of credit and thank you goes out to the team at Northwestern with Yuri Olensky's group, growing out of the NetLogo team there, which was and Yuri's previous, his advisor at MIT, Seymour Papert, all this kind of logo thinking. And so this modern evolution is how do we now take that work and bring it into the browser and make it distributed and shareable and embeddable in other languages, which we'll show today. So agent-based modeling, you can think of one of the three major simulation categories. Everyone has different categorizations, but for me, you kind of have system dynamics or a series of coupled differential equations is one way. Discrete event simulation is a second. And agent-based modeling is a lens you can put on modeling a system where you have three primitive interacting components or elements that we call agents. They can be the turtles that are flying on the screen, and that has the legacy term from the logo days. It's something that can move in space. It's a point and a heading, and it moves in space, like the ants you're seeing on the screen. Or here's a flocking model, and this could be a fish or a bird. And then you have the second thing is the patch, which is the yellow pheromone you're seeing right now. So that's a regular graph or grid that has a value. And that would be if you're like at Los Alamos, a Lagrangian versus Eulerian approach. So the ants would be a Lagrangian and the patches would be Eulerian. And the third type of agent, which we'll briefly show here, is a link, which connects the relationship between two turtles. And all three of those are agents that can be scripted and have behavior. And so even the links we consider agents. So with that, we're going to walk you through the site, and Benny's going to give you a little tour here of how you interact with AgentScript in the browser.
So the first, if you just scroll down from the home page, this will be at agentscript.org. You get to just a little how does it work section that introduces turtles. And there's a little empty world, this black square on the right. And so this will walk you through with these little code blocks that you can edit the content of and run, how to create turtles and give them behaviors using the AgentScript language. So first we'll just make a few here. We can change this to 10, make 10 at a time. Now we have a whole bunch. This is how we'll make them all move forward. And it just kind of like builds up slowly, one command at a time, kind of walking you through how to give these turtles behaviors. A little further down, you get to run things in an infinite loop, which is how you'd normally be modeling. And you get to work with patches too. So now these turtles are all wiggling around randomly and writing a bunch of chemical pheromone into their grid background that's colored yellow or purple. And here you can see we can change what that color scheme is, like this. So we're trying to make the introduction really accessible and interactive. The next kind of resource that you turn to after this tutorial is this examples library. So here we got a few basic examples like ant foraging and slime mold aggregation that I'll get into. There's also a 3D renderer, which is pretty cool. So you can be writing your models in 3 dimensions instead of 2. I'll go back to the slime mold for now. So this is like an extension of that tutorial model we were just looking at. So right now, these agents, they're leaving a chemical trail in this background grid of patches. And the more pheromone, the yellower it is, and the less, the more purple it is. And then whenever they move, they look in front of them and to the left and to the right. And whichever of those patches has the most pheromone, that's the direction they move in. And so this is the code for that model here. It's kind of heavily commented because this is the tutorial code. And so you can try just changing some of these parameters and seeing what happens. So if I change this wiggle angle, which is like how much the agents turn, that changes quite a bit whether they're able to aggregate into these clumps. And this model was inspired by actual cellular slime molds and how they are able to coordinate the behavior of grouping together into like a multicellular organism. So if I bring this back up to like 40 degrees, then they have a much easier time forming these clumps. There's also some controls here. So you can pause the model and then step through it 1 tick at a time. You can reset if you want to start fresh. There's also a view tab. So this is where you change how the model gets rendered. So I'll play this one, and then here again, like let's say instead of this black, purple, yellow color scheme, I wanted orange to red.
And being in Santa Fe, can you make that Christmas, Benny?
Yeah, I'll do green to red.
Thank you.
I can change the size of the turtles, make them really large. And then let's say you get to a model setting that you are happy with, that you want to continue working on later. There's a couple of different export options. So the first one is this thing called a pebble. So if you click this export pebble button, you will end up downloading a PNG. So now let's say you come back to the editor and it's you've reloaded the example, but you want to keep working on that model you were just looking at. So now if you open up the pebble you just downloaded, let me find that. You've got this slime mold model PNG. Now if you drag that over here, it will reload the code you were working on. So even though it looks like a image, all your model code is actually embedded in here.
And that's something you could send to somebody via email or text, or even on Facebook, and it will keep that information inside the image. Yep.
And the second way to save your work for later is to just export the entire editor window as an HTML file. So if you click on that, then you wind up with this. Everything is embedded in this single file, and you can open that and just work from here.
And that can run offline, if you're not connected to the network. Yep.
Yeah, it's totally standalone. And it's going to be helpful to have a few resources to turn to when you're working on these models. So the first one is the docs. So let's say we were wondering about like this patch right and ahead command. We could go to the docs. I'm having trouble switching tabs. And type in the beginning of that command, and then we'll see what source files this thing shows up in. So here's patch right and ahead. It tells you what the arguments are and what it does. The documentation is definitely still a work in progress. So a second resource that's really helpful is just the GitHub page. So this is an open source library that Owen has been working on for a while. And I'll turn it over to you, Owen, I guess, to walk through. I'll go into the source directory here. Do you want to say a few things about the code there?
Yes, the source directory is basically where all of the source that's being used at the lowest level within the system lives. And it has, for example, the geo world that you're seeing there is a way to write GIS or geospatial models. And and all of this is available. There's another directory called modules, which use these to put what you've seen before. So there's a fire model and that kind of thing, flock model, etc. So if you want, I can drive you through from here. Would that be good?
Yeah. You want me to stop sharing?
Let me grab the screen.
Just like in rehearsal.
Yeah, this is really great. And boy, okay, let's see. Am I over here? Can you see my screen?
Mm-hmm.
Okay. Well, this is where we were just then, and I'll say a little bit more about the source world. This is something called a repository, and it lives in a web world called GitHub. And you can see what you saw before. All of the source, for example, the source directory we saw before, and also the models, etc. So this is where the basement of all of AgentScript is. If you want to think of it as in terms of, well, we have a very accessible piece, but then there's the programming piece itself. It's an unusual repo in the sense it's extraordinarily modern from programming standpoint, and you can see some of that information there. But what I'd like to do is show you this running a little bit more live. In other words, GitHub itself supports a way where you can actually run the programs that you put into it. So let me give you an example of one of those. Inside the models directory, there's one that actually has the links, which we didn't see before. This is, we have turtles that are running around and other turtles that are these little nodes, but we also have links that we developed, and the turtles are learning how to crawl along the links to create the illusion of traffic, for lack of a better word. The whole idea behind AgentScript was to be able to do easily what many of the research has done in the past, and as Steve mentioned, with the three different kinds of simulation. One of them was Craig Reynolds back in 1986 wondered how flocking worked. How do birds do what they do? And he has this lovely thing about that they avoid each other, they try to align with each other. And so, again, running on from the source, and also in the IDE that Benny showed you, you can go ahead and run this. I'm going to make it a little bit bigger so you can see it better. And you can see this lovely flocking behavior, which is so pleasant. But more importantly, and from one sense, is the reason we have this low-level source is so that we can embed ourselves in unusual situations. So for example, we're looking at a map here that's a piece of software that knows nothing about AgentScript, nothing about modeling, but we're able to use it. And then in this particular example, we're going to run what we call a droplets. Think of rain falling, and what it's doing is it's using the GIS or geospatial information of the terrain that we're looking at to let the droplets flow downhill. And this is where I started. Okay, this is where the Redfish IDE, where you just saw, lives. I won't go any further into that.
Okay,
So
thank you.
Okay, let me give the screen back. Sorry.
And I'll just kind of point out what Owen was just showing with the docs and the code. I'll just show as we're in the browser as well, running the same cellular slime mold. Let's say we were interested in this piece of code, and you do have being in the browser, we do have access to the debugger as well. So I can set a breakpoint when this is running. And right now, one of the turtles that's executing the first turtle ID 0, but I can skip ahead to maybe the second turtle, third turtle, and we have different and patch ID 50. It happens to be on patch ID 1519 right now. But if I really want to know how patch write ahead works in the source right now, I can now drop in to the scope and follow that code. And now I'm in AgentScript, right? And I can actually see the code that was in the repository that Owen showed, and it's bringing the current values that it's running with, and I can debug. And it's just kind of cute to me that patch right and ahead. Well, that's very similar to patch left and ahead, but I just changed the negative angle. So that's so you can get into the kind of the weeds of how this works. And if you have ideas that should be at basically the core of AgentScript as an open source tool, you can fork it and then do a pull request and and add to it. So we encourage that kind of participation. And then just as I conclude, go ahead, Owen.
You'll be rich and famous.
Yeah, like all open source projects. And just as a final thank you and tribute, I'd just like to thank, this has been a labor of love for Owen. So he mentioned, back in the day, he was one of those guys that this wild guy stole from Xerox. And here's Owen in the stack at Apple making the first Macintosh. So a lot of you might recognize some of these names down here, but Owen brought printing to the Macintosh. And I think this is his next project. He turns 50 next year in hexadecimal. So I think there's not many developers still kicking and doing amazing work. So Owen, I really just want to thank you for bringing this to us personally, but also just to the community. And we love you, man. Thank you. And that concludes our tutorial. Any parting shots or words, Benny or Owen?
I think that's great.
Okay. And that's a wrap.
Sweet.